We are on page 6 of your Unit 5 packet, and we'll be talking about special right triangles today. The first video is on what we call the 45-45-90 triangle, and the second is 30-60-90. The common angle is 90. So specifically speaking, we're talking about two types of right triangles. The 45-45-90 triangle means that the two acute angles besides the right angle is 45 degrees and 45 degrees, like you see below here. And then the second type is 30-60 is the measure of the acute angles. And what we'll be doing today is coming up with a pattern based off of first looking at Pythagorean theorem on the 5 problems that you see here. So I will start you guys off. I will do number 2 and then have you guys go ahead and try the other 3, 1, 3, and 4, and then see if you can figure out what you think 5 might be. So let's say that we have the set of 5 triangles, and on number 2 I use Pythagorean theorem, which is a squared plus b squared equals c squared. And from the other day we talked about the a and the b must be the legs of the triangle. So we have 2 squared plus 2 squared equals x squared. So to solve for this, we get 4 plus 4, 8 equals x squared. Solve for x by taking the square root of both sides. X equals, and 8 you guys can break apart from the other day we discussed, 2, 2, and 2. So therefore one of the 2's can go outside, the other one stays in, 2 radical 2. Now go ahead and hit pause and complete 1, 3, and 4 with Pythagorean theorem. Okay, at this point you guys should have completed number 1. You would have gotten x equals radical 2. For number 3, you would have gotten x equals 3 radical 2. And number 4, you would have gotten 4 radical 2. And number 5, go ahead and enter what you think number 5 should be. Okay, good. The answer is 57 radical 2. So after observing this pattern, we can then say if we wanted to go from one of the legs, if we're given one of the legs, and we wanted to go to the hypotenuse, we can simply multiply the leg by radical 2. So in the blank spot here, let's go ahead and say multiply leg by radical 2. Now if we think about going in the direction from the leg, which is shorter than the hypotenuse, we're multiplying to get from rad 2. Now if we were given, let's think about a problem where we're given the hypotenuse instead, and how would we then go back to get the leg? So if we knew this was 3 rad 2 and our x was one of the leg values, this was 3 rad 2, how would we get back to that? So good, if you're thinking of inverse operations and you thought, oh, to go backwards, to go the opposite of multiply is divide. So we would divide the hypotenuse by radical 2. So if we want to go bigger, we multiply. If we want to go smaller, we divide by. So let's see our first few problems. Let's try a few examples. So we're going from a leg, which is shorter, to the hypotenuse. So in this case, we would be multiplying. So x would be 17 rad 2. Let's take a look at number 9. Number 9, again, we're going from a leg to a hypotenuse. So multiply by radical 2. Go ahead and try that. Okay, we should have gotten that. To get from the leg to the hypotenuse, we take 1/2 times radical 2. Oftentimes we rewrite that as radical 2 over 2. So that is the leg value. And let's see number 11. Sometimes it gets tricky because we're looking at it and thinking, okay, maybe we divide by radical 2, but just keep in mind we're going from the leg to the hypotenuse. So if we're getting bigger, then we want to multiply. So in this case, x equals, the hypotenuse equals radical 2, the leg times radical 2. So in this case, radical 2 times radical 2 is radical 4, or in other words, just 2. Now let's take a look at the row below there. So what is the difference between this top row and then this bottom row? Okay, good. We should have said that we are dividing Here instead, because we have the hypotenuse and x is now one of the legs. And remember, this is a 45, 45, 90 triangle, so these are isosceles triangles, so we're going reverse. So in this case, we take 13 rad 2, so we take the hypotenuse and we divide by that factor of radical 2. So in this case, radical 2 over radical 2, those reduce, and we get x equals 13. And that should make sense, right? Going from the leg of 13, we can get 13 rad 2. Going from 13 rad 2, which is the hypotenuse, back to the leg, we're going to divide. Okay, so go ahead and try number 14. So good, you should have gotten x equals 26 rad 2 divided by, remember we're going from hypotenuse to leg, so we want to divide instead of multiply. So dividing by rad 2, that gets you x equals 26. Now the trickier questions will have radical, it really isn't difficult because of the operation, but because of just simplifying radicals. So let's take a look at 16. So what happens if you're given the hypotenuse, you know you have to divide by radical 2 because you're going backwards to get the legs. So in simplifying this type of radical, we do something called rationalizing. And rationalizing means that one of the rules for radicals is that you cannot have a radical at the bottom of a fraction. And to make this so that there's no radical on the bottom, what we essentially have to do is multiply the denominator by the same thing as itself. But when we're multiplying a fraction, we can't simply multiply the denominator by radical 2. We have to multiply both top and bottom, because essentially this is 1. So multiplying something by 1 isn't going to change the fraction. However, doing so, what happens is we can now give a partner to the bottom 2. So we have 6 times radical 2 on top. So multiplying the 6 to the rad 2, we get 6 rad 2. Multiplying rad 2 by rad 2, that's the same thing as rad 4 or rad 2 times 2. Perfect square here. So that allows us to take out a 2 and not have anything else left inside the radical. Or you can think of it as square root of 4, and square root of 4 is just 2. And so on top, 6 times radical 2 can be reduced by the 2 at the bottom because those are factors. It's like saying 6x over 2, and that's just 3x. So what we do is we reduce the 2 with the 6 on the outside, and we get 3 radical 2 is the mathematical equivalent of 6 over rad 2 without having a fraction on the bottom. So we're going to try this 2 more times. I want you guys to go ahead and try 17 and enter your answer in. Okay, so let's check our work. 48 divided by radical 2, because we're going from hypotenuse back to leg, going smaller, so we divide. We're going to multiply top and bottom by rad 2. Okay, so again, multiply top and bottom by whatever the denominator is. That's going to get us 48 times rad 2. At the very bottom, rad 2 times rad 2, same thing as over here, is just 2, because it's the square root of 4. 2 goes into 48, 24 times, 24 rad 2. I want you guys to enter in your answers for 18 as well. Okay, so with this problem, we see that we don't have anything to cancel out. So rad 2 is on the bottom, so we multiply top and bottom by rad 2 over rad 2. We get 5 times radical 2 on top, and then rad 2 times rad 2 is just 2. 5 over 2 doesn't reduce. We want to think of that as a fraction. It doesn't but reduce by a common factor. So our final answer is 5 rad 2 over 2.